Hello. The next chapter in this class is called AC power analysis. So it is talking about mainly how you calculate the power in AC circuits. So we have some definitions here. We have something called instantaneous power, and we have something called average power. And the word instantaneous here means that it is actually temporary. It is a function of time. Instantaneous, so it is a function of time. This is a power as a function of time. Instantaneous power. So for example, if this is a power here, you see the power is changing with time. It has a certain average value here. Okay. So the power, the instantaneous power equal what? Equal V of t time I of t. Exactly like in DC, the voltage equal voltage, the power equal voltage time current. But the only difference here is that it is a function of time. Then in general, if V of t is just Vm cosine omega t and theta V, this is a phase for voltage and this is a current. Then when you multiply this means that it will be Vm time Im. You multiply Vm time Im cosine, 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 cosine. And if you remember from, I believe, the previous chapter, maybe, if we have cosine, cosine, you can convert it to cosine. You add the two angles and then you subtract the two angles. So it's cosine, cosine, cosine x time cosine y. I believe it has some relation with that cosine x minus y and cosine x plus y, something like this. Can't remember exactly, but it has one half in outside. So if you use this relation, then the power of power as a function of time equal 1/2 Vm time Im cosine the difference. See the difference between them. So omega t will cancel here, so it will be theta v minus theta I plus 1/2 Vm Im cosine the summation here. 2 omega t plus theta v plus theta I. Then as you see here, you have the power is two terms here. One is constant, which is this one here, and the other one is variable, is a function of time. So this one is not a function of time. So when you plot it, you will notice that this one here will be the average, okay, and this one is the one that is variable. So you see here, the average power is this value here, which is 1/2 Vm Im cosine the difference between theta v and theta I. And this part here is a variable part. We call this the average power. So if you want to calculate the average power, it is 1/2 Vm. Vm is the maximum voltage and Im is the maximum current, cosine the difference between theta v and theta I. So here, this is what we call it. See the average power. The average power is that simply 1/2 Vm Im cosine theta v times theta I. This is the average power. In case if you have, for example, resistor, if you have resistor, then in this case, there is no difference in phase between voltage and current. The resistor does not provide phase shift. Why? Because V equal I times R, and R is just real. So you don't have phase shift between V and I, VR and IR. So in this case, theta V and theta I are the same. Then cosine theta V minus theta I will be cosine 0, which is 1. Then this is the power here, 1/2 Vm Im. This is for resistor. For capacitor, the capacitor and the inductor will give you a plus or minus phase shift, 90-degree phase shift. Because, for example, for the impedance for the inductor is J omega L. So actually it is J is 90-degree. Omega L is just constant. Okay, and for the capacitor, it is 1 over J omega C, or you can say negative J over omega C. And negative J by itself is negative 90-degree. So the capacitor and the inductor will add a positive or negative 90-degree phase shift. Then there is a 90-degree phase shift between theta V, between voltage and current. Then the difference here will be 90-degree. And cosine 90-degree is 0. So this means that if you have any capacitor or inductor, the power absorbed or the average power is 0. So you don't have to calculate it here. So if you have a circuit and I ask you to calculate the average power, and for the capacitor, you don't have to even calculate it here. It is just 0. But if you have a resistor, you need to calculate it. Look at this example. We have a voltage and we have a current, okay? And we need to find the instantaneous power and the average power. The instantaneous power, you just multiply them and use this formula here. So P of T equal what? Equal 1/2 Vm is 120, Im is 10, cosine the difference between the phases. So it is 45 minus 10 will be 55 degree. So cosine 55 degree. Plus 1/2 Vm again is 120 time Im, which is 10, cosine 2 omega t. Omega here is 377 t, so it will be 3 times 377 t plus you add the two angles here. 45 and negative 10 will be 35. So this will be the instantaneous power. The average power, so when you calculate it, will look like this. You can just use the calculator here if you want to calculate it. So here is 1/2. 1/2 is just 0.5 time 120 time 10. Okay, so this is 600. Okay, 600. So this one is 600, and you multiply it by cosine what? Cosine 45 minus 10 will be 55. So time 55 degree cosine equal 344.2. 0.1 is 0.1. Okay, it's almost 0.1. I don't know why it's said 0.2. But here, this is so this part here is average power. So if I ask you to calculate the average power, you don't have to do this step here. You don't have to do it. It is already there, 344. Okay. For the next example, what does it say? It say here for the circuit, this circuit here, find the average power. So the average power is cosine is 1/2 Vm Im cosine theta V minus theta I, supplied by the source. So we need to find the average power in the source and absorbed by this resistor here. If I ask you what is the average power in this capacitor, it is 0. It is 0. You don't have to calculate. Okay, so let us see here the power in the source. So power in the source is V times I. So V here is 5 and 30 degree is given. We don't know I, so we need to calculate I first. Okay, I is the voltage 5 and 30 degree divided by the total impedance, which is 4 and minus J2. So here it is. We convert this to amplitude and phase. So 4 square plus 2 square under square root, and you take the angle here of -2 and 4. As I mentioned before, remember you have to be careful when you calculate the angle, because sometimes when you have a negative and positive here, because look at this angle here, it is -2, 4 is a positive, the real, 4 is the real, and the imaginary is negative. Then this is a vector here. So this is 4 minus J2. So you know that this is the angle. The angle will be negative something here between 0 and -90. So let's take the calculator here and say, okay, I need -2 divided by 4 equal, and then inverse 10. So this is the angle here, -26.56, which makes sense. Okay, so this is right. But if it is, for example, -4 plus J2, then the angle will be in the other side. So this is the angle here. So you have to add 180 degree to this result. So you have to add 180 degree to this one here. Okay, so it will be plus 180. So it will be 153 here. Makes sense because it's supposed to be between 90 and 180. Okay, so you calculate I, and I, you can say 5 over 4.472 equal 1.18, and 30 minus will be plus. So this is the angle here. So we have now I, and we have V, which is 5 and 30. So if you want to calculate the power, you use this relation here. 1/2, the voltage here is 5, Vm is 5, the current is 1.18, 1.118, and cosine the difference between them, theta V is 30 and theta I is 56.57. Then you can calculate this power. It's 2.5 watts. Okay, so this is the power generated by the source or supplied by the source. Okay. If you want to calculate the power absorbed by the resistor, without thinking, it is 2.5 watts. Why? Because if you this source will generate 2.5 watts. Okay, so these two loads here will absorb this power, but we know that the capacitor absorbs zero because of the 90-degree phase shift, as I mentioned before. The capacitor and the inductor have zero power. So all the power will be absorbed by the resistor. So if this one provide 2.5 watts, then this one absorbs 2.5 watts. But you still can prove it. How can you prove it? You use the same equation, Vm time Im cosine theta V minus theta I. But you are talking about the voltage across the resistor and the current. We know the current. We have the current already here, which is this one. This is the current. Okay, and what is this? 4 here? 4 is the ohm resistance. So you need to calculate the voltage. We need to calculate this voltage here for the resistor. So it is 4 times the current. 4 times the current. So it will be 4 times the current. You multiply this by 4, will be 4.472. Okay, now you substitute in this equation. So it is 1/2. You want to calculate it. It is 1/2 0.5 time Vm here is this one here, 4.472. Okay, time the current here Im is this one here, 1.118. Okay, here it is. Cosine the difference. And what's the difference here between 56 and 56? Is 0. So cosine 0 is just 1. So the power is what? 2.49998 whatever. So it is actually 2.5 watts. Okay, so as I said, you don't have to calculate VR. It makes sense that all the power will be absorbed by the resistor. But if you have multiple resistors, okay, then in this case you have to calculate it. Okay. Let us look at this example. We have two sources here, so you really don't know here which source. Both sources are providing power for sure, but one of them will provide more power. So let us see what happened here. Find power for all sources and elements. Okay. So if I give you this problem in quiz, for example, you will get credit for just saying, okay, the power in this inductor is 0, the power in this capacitor is 0, even if you do not solve it, because we know that this is supposed to be 0. We know that. Why? Again, because of the 90 positive and negative 90-degree phase shift, and you know that cosine 90 is 0. Okay, so all the powers that we need to calculate is this one here, and of course the two sources. So if you want to calculate it, you have to use a formula. So you need for the voltage and the current. For example, for the source, for the current source, I know the current is 4 ampere, but I don't know V1, this V1, the voltage across the source. I know the voltage here is 60 and 30 degree, but I don't know the current, which is supposed to be negative of this current here, supposed to be going in this direction here. Okay, so I need to calculate the current here. So you have to solve this circuit like what we did in the previous chapter. Yes, the previous chapter was the steady state analysis. So, or you can use a nodal analysis or mesh analysis. Here, I choose to use mesh analysis because I know the current here. You can also use nodal analysis if you want. Okay, so here, this current here is just 4 ampere. You don't have to calculate it because you know that this current here, the current in this mesh here is the current in the source. So it is 4 ampere. And the current here is just I2, so you have to write equation for I2. So I2 time what? I2 times J10 minus J5, which is the total here is J5, time I2 minus the intersection I1 times J10. So here it is, this one here, equals the source. So the source is opposite to the current because it is more going up, negative to positive. So opposite to I2, so it will be negative 60 and 30 degrees. And you can move this negative inside. So negative inside, it means that you add 180 or negative 180. And you substitute by I1 equal 4. So I1 is 4 here. So this one will be negative J40. J10 times 4 will be negative J40. You move it to the other side. Okay. So you have only one unknown here, which is I2. So J10 minus J5 is positive J5 equal negative 60 and 30 degree plus J40. Then you can simplify this by calculating. Of course, you divide here by J5 to get I2. So you divide everything by J5. J5 is just 5 amplitude. So you divide by 5 in amplitude. So 5, when you divide by 5, this will be 12. And this one will be 8. And when you divide by J, okay, so it will be divided by J. It is actually 1 over J is negative J. So as if you add a negative 90 degree phase shift, negative 90 degree for this one here, and for this one also here. Okay, but negative J times positive J will be 1. So this will be 8 here. Okay, so again, if what happened here is that we divide by 5 to get rid of this 5. Okay, so this number 1, 5, 5. Okay, and then we divide by J also. When we divide by J, okay, this J will cancel with this J. So 40J divided by 5J will be 8. Okay, and 60 divided by 5 is 12. And this J, when you divide by J, actually it is as if you multiply by negative 90 degree or add a negative 90 degree in phase. Because J is 90, in the denominator, if you move it up, will be negative 90. You add it to 30, will be negative 60. So this will be I2, and then you can calculate I2 like this. This will be the final answer for I2. Then now if you want to find the voltage source power, this voltage source power here, then you need to calculate this current, multiply this voltage times this current. This current is negative I2, negative I2. So it will be negative of this one. So as if you add, so this current, if I said this one is IS, for example, okay, so IS, you just add a negative or 180 degree to this one. That's it, because it is negative of this. Or you subtract, you add or subtract, it doesn't matter what you like. So the voltage source power is what? Is 1/2 Vm, here it is 60, times 10.58, this is Im, cosine the angle here, the difference. What is the difference? There's a voltage 30, okay, and here you have minus this one here, which is 79.1, and as I said, you can add or subtract 180 degree. Then the total, you will find that this power look like this. The answer here is negative. So what does this mean? This means actually that this source is absorbing power also. This means that the current source is providing more power, that the voltage source will get some power, then for the source here, you need to calculate V1. For this source, you need to calculate V1. So V1 here, use Kirchhoff voltage law. V1 equal V2 plus the voltage across the J10 inductor here. Okay, so this for this loop, in this loop, okay, you just need to calculate V1 equal V2 plus the voltage across the inductor. So V1 equal what? Equal 20 I1, the current time resistance. 20 is the resistance time I1, and then plus J10 time what? Time the current here. The current here is what? The current is I1 minus I2. This current is I1 minus I2. So this one is I1 minus I2. So you multiply current time resistance. So J10, I1 minus I2. So of course I1 is 4. So 80 for 20 times 4 is 80. And this one is 4 also again. And this one I2 is given here. So you just need to transfer this from amplitude and phase to real and imaginary to be able to add or subtract. So I2 equal what? I2 equal what? Equal, you can calculate it here. Here's the current I2 is what? Is 10.5 8 time 79.1, 79.1 cosine. This is the real part, equal 2. So it's 2. So the real part is 2. So this one here is 2. Okay. And the imaginary is what? Let's see here. The imaginary is sine, so it will be 10 again, 10.58 times 79.1 sine, here it is, equal 10.3, almost 9, 10.39. So it is plus j 10.39. Okay, so it will be 4, this 4 ampere minus 2 minus j 10.39. Of course, 4 minus 2 will be 2. Okay, and then you can convert this back to amplitude and phase. Then this will be the voltage across the current source. Now to calculate the power in this source, it is 1/2. The voltage here is Vm is 184.984. The current is 4 ampere. Cosine the difference between them, which is 6.21. This 6.21 minus 79. Minus what here? For this one here, yeah, minus 0. Yeah, minus 0. This is the angle here is 0. The angle here or the current here is 0. Okay, so you can calculate this. It's very clear that you can calculate this one. If you want to calculate it, it is like this: 0.5 times 184.984. Okay, time 4 times 6.21 cosine equal 367.8. Okay, and then if you want to calculate the power of in the resistor, you have two ways to do that. One way is to just calculate to use a formula 100 1/2 the voltage here. This one here is 80. It is 80 volt because the current is 4 ampere. 4 times 20 is 80. So 80 times the current is 4. So 1/2 80. 4 times 4 will be 160. Okay, so this is a power here. 1/2 80 times 4 will be 160. Another way to do that is what? Is that you know that the power you have in this circuit, look at this per circuit. You have two sources and you have resistor. These are all the power will be in these three items. You have a power in the voltage source is negative. You have the power in the current source is positive. Then the total power from the sources are what? Or this one here is 367.8, and the other power is 207.8, and it is negative. Then the total power absorbed by the elements is 160. So the total power from the two sources is 160. Okay, and the only elements that absorb power here is the resistor, so it will be 160. So you can calculate it this way, or you can calculate it as we have here.